Hello and welcome to another episode of Science with Isabelle. Today I will be showing you my hand-powered electric generator. I've got some wire, I've got some magnets, and when I spin the magnets, the light bulb lights up. So how does it work? Coming up next on Science with Isabelle. So how does wire plus magnets equal electricity? In 1831, Faraday discovered that a changing magnetic flux can induce an electromotive force in a coil of wire. He created Faraday's Law. EMF equals negative N delta phi over delta T. EMF is basically voltage, and we know that if there is a potential difference in a wire, current will flow from high potential to low potential. N is the number of turns in the coil. The more turns you have, the more current you'll get. Delta phi is the change in magnetic flux, and that's time. Having stronger magnets means more current, and moving the magnets faster, so less time, means more current as well. The negative sign denotes Lenz's law. So what's Lenz's law? Lenz's law states that when a changing magnetic flux induces a current, the current will flow in such a direction as to create its own magnetic fields that will oppose the change that created it. Consider a loop of wire, and you bring a north pole into it from the top. So the flux is increasing this way. Lenz's law states that the induced current will flow in such a direction that its own magnetic field will oppose the change that created it, so this way. Consider the opposite. If the induced current flowed this way, then its own magnetic field would also be down. The magnetic field would just get stronger and stronger, giving you infinite energy, and that's not possible, so Lenz's law must be true. So now that we know how magnets can induce electricity, let's talk about how to build a generator. First, you're going to need a frame for your coil. I've made mine out of cardboard so I could customize it to the size of my magnets. Then you're going to need a coil of wire. Mine has 400 turns. You're going to want 30 gauge wire. Any thicker and the coil might get too bulky and the magnetic field might not be able to reach the wire on the outside. Any thinner and the resistance goes up, because resistance is inversely proportional to the cross-sectional area. You'll also want to make sure your wire is enameled, because otherwise all the wire will just connect and you'll really only have one turn, and that's no good. I've attached my magnets to a metal nail, so I can use it as an axle to spin my magnets. Going to need strong magnets. I've got 4 neodymium magnets, and they each have a 15-pound pull, so these are very strong. Be careful with them. Is this safe enough? Okay, maybe not that careful, but these magnets can pinch your skin or ruin your electronics, so be safe. And finally, I'm using my generator to light up a light bulb. This is a 1.5 volt, 25 milliamp miniature light bulb. So let's build a generator. First, we're going to start with some cardboard. I got my cardboard from a Kleenex box, so I'll just break it down. Got some cardboard. And then I'm going to measure out a 30 centimeter by 8 centimeter rectangle. And then cut it out. Fold it into your frame. Use some tape to keep it together. Then you're going to want to make a nail hole through the center. And then make sure the nail can spin easily. And then we'll just take the nail out for now. And we'll take some wire, and we're just gonna tape it to the inside so we have some lead wire. And then we're just gonna wind it around 400 times. So now we've got our 400 turns, and I'll just cut that off right there. And then you're going to need to burn off the enamel on the ends, otherwise you won't have any copper and it's not going to connect to the light bulb at all. And burn off like 1.5 inches of the enamel. and attach each wire end to your light bulb. And make sure the bare ends from either end of the coil don't touch, otherwise you'll create a short circuit, and that won't be good. Put the nail back into its nail hole, and then take half of your magnets and stick them to the nail inside, and then take the rest of your magnets and put them on the other side of the nail inside so that the two stacks are attracted to each other. And then use some tape to keep them together. And now you've got a generator. Well, that's it for today. Thanks for watching, and I'll see you next time on Science with Isabelle.